Jen. I'm a network engineer at Google in Australia, and I've been with Google for like more than 10 years, initially working on production backbone, and for the last 6 years, I've been looking after corporate part of the Google network, and all of the time, I've been mostly working on IPv6. So today, I'm gonna speak about something really exciting what I've done, about something I broke. So let me show you some slides. And another thing, you need to know about me is that I'm a big fan of Comic Sans. So some people might be suffering for the next half an hour. Sorry about that. So what I'm going to talk about today is something people might consider almost impossible, almost like unicorn. My talk will be about turning IPv4 off in the enterprise environment and migrating an enterprise network to IPv6 only mode. Why? Why would any sane person do that? I actually had plenty of reasons to do that. First of all, believe it or not, we run out of IPv4 address space. Yes, private one. It's possible. Secondly, I am getting more and more requests from various business units and developers for IPv6 only environment for dog food and testing. And last but not least, I'm heavily involved in operations. And I found that dual stack network comes with a cost. Operating dual stack is actually harder than operating single stack network because you're basically operating two networks at the same time, and you need to make sure their configurations are consistent, and troubleshooting is a bit tricky thanks for happy eyeballs. So, in our attempt to save private address space, IPv4 address space, and simplify the network, we decided to try something impossible and turn off IPv4 in the part of the network. To do the pilot and proof of concept, we decided to take the low-hanging fruit and migrate our corporate guest network to IPv6 only mode. Our guest network actually consists of two parts. One is guest Wi-Fi. If you ever visited one of Google offices, you probably noticed that we have Google guest Wi-Fi, which is open in most of the offices, and you can connect, visitors can connect their devices. Actually, it's the biggest Wi-Fi network we have in the corporate environment. Most of our Wi-Fi users, more than half, are actually using guest Wi-Fi. Also, we have a wired guest network, which is used for unauthorized, unknown devices connected to a wired Ethernet, and also it's used as a fallback network in case of .1x authentication fails. So, how we did that? Obviously, we still need to provide access for guest devices to IPv4 only internet resources. So what we needed is NAT 6.4 and DNS 6.4, which obviously are the key element of providing access to it for destinations. For DNS, we were using Google Public DNS 6.4, which we launched in 2015, as far as I can remember. Because for normal dual stack guest network, we're also using Google Public DNS, so it was obvious choice. We don't have any form of DHCPv6, it's pure Slack, so we were providing DNS 6.4 information to host via RDNSS, so DNS IPs were sent in router advertisements. For NAT 6.4, for translating IPv6 traffic to IPv4, we were using the same devices which were in dual stack environment doing translation from private IPv4 address space to public IPv4 address space. Those devices located to site edge, so it was easy basically. No new network elements, the same path for traffic. We just replacing one form of NAT with a NAT. When we started the pilot for guest network, I wanted to answer a number of questions, which could be summarized as what exactly will be broken, because you don't know what you don't know, and guest devices, by definition, devices we do not control, and we have no idea what they are. How many devices actually can stay on V6 on the network? I had some guesstimate because it's not the first IPv6 only network I've seen. A number of conferences do the same. For example, RIPE has V6 only network as well. As far as I know, FOSDEM is doing V6 only, and we actually did some experiments at ITF network as well. I expected that maybe 75% of devices would be okay, but obviously it would depend on the environment, so I needed more solid numbers. Also, another interesting question was how our tech support would survive, because some people were concerned that we might get too many unhappy customers. So we decided to do some tests on this. I selected 12 sites for the pilot, and obviously, if you decided to try this at home, your experience may vary. I had 4 primary criteria. First, those sites had to have network operations people on site to simplify the troubleshooting. So I actually started from my home Sydney office. I wanted to do the pilot on locations when we have a large number of users to make the data more statistically reliable. And also I took into account customer demands. So sites where we get most number of requests for IPv6 on the network from developers were included into the pilot, because it meant that we'll get users there and those users are willing to try that network and help us finding issues. So as I mentioned, we had 2 segments, wired and wireless. And we did pilot for them separately. For wired, it was easier. For about 6 or 9 months, we just turned off IPv4 on the segments, converted into V6 only. I mean, replaced DNS with DNS 6.4. And for users who need IPv4, we provided a self-service portal to re-enable IPv4 on the given wired port. But users were asked and encouraged to tell us why they requested IPv4, because as I mentioned, one of the goals of the pilot was to find out what is broken and why. So we'd like to enumerate all possible issues. So for any deployment story, the most interesting part is always what got broken, right? Everyone wants to hear the worst story. So the biggest breakage I caused happened on the first pilot site right away, and it probably was the biggest issue we discovered. I mean, in terms of number of people unhappy and how urgent it was to fix it. And what I broke was Treadmills. Yes, we have a number of offices where we have gyms on site, and those gyms have all these smart exercise devices, which are connected to the internet. I didn't even notice until all this project happened, right? Apparently, those devices need internet connection, and most of them are really not happy when you take IPv4 away. So, fortunately, we were able to recover those devices, providing them IPv4, and we started discussion with Treadmill vendor, actually, about fixing the problem. And we're still waiting for them to come with a new version which will support IPv6 on the network. So, as I said, about 6 or 9 months of the pilot, the results were actually quite good. Most of the sites, except ones which had Treadmills, did not need many IPv4 enabled ports. The maximum number we saw like 5 devices per site, which allowed us to save a lot of address space, because a wired network had to be provisioned to allow all our corporate devices to end up on the guest network if .1x authentication failed. So we had to provision a lot of address space for dual stack wired guests. And by making IPv6 only, we were able to recover, I would say, 200,000 or 300,000 addresses actually. And main IPv4 use case we discovered on the wired guest was various types of embedded systems like Treadmills, IoT stuff, not actual laptops. It was mostly some special devices which didn't even know about V6. So for wireless, we decided to take baby steps. So we did the pilot in two phases. Phase one was opt-in, which lasts for a year and a half. During that phase, we created a special dedicated new SSID on the pilot site. We sent an email to all users on site and asked them to try the new SSID and report the issue. And after we became confident that we're not going to see too many problems with IPv6 only, we switched to opt-out. For about 9 months, we made our primary standard Google Guest SSID IPv6 only. But for users who still need IPv4, we created a special dedicated fallback SSID, which had not existed on those sites before. And again, we asked users, please come and tell us what's broke and don't just switch back to dual stack SSID because we need to know what is broken. So what we found during the pilot on those 12 sites. For Wi-Fi, phase one, about 10% of users actually tried new SSID, which was much, much better than I expected. You know, people tend to ignore such emails. But yeah, 10% of them moved. We asked users to report bugs, and we even offered a draw. So the winner, person who reported the most number of bugs, was supposed to win $100 donated to a charity of their choice. Actually, we got 15 bugs reported, and 3 of them were fixed as a result. Well, it's a typical situation with operations, nothing gets fixed until people complain, right? So before even we start moving majority of the users to V6 only, we already have some bugs fixed. When we moved majority of the users to V6 only, we noticed that less than 5% of users fall back to dual stack SSID. That was actually much, much better than I expected. My guesstimate before the start of the project was maybe 25%. Well, actually, 10% of those users were using 2.4 gigahertz SSID, which we did not migrate to V6 only. So out of all guest users, we have 10% which stayed on dual stack because we did not touch them. 5% fall back to dual stack SSID. So basically about 85% of our users were quite happy being on V6 only network. In absolute numbers, it's actually quite a lot. The peak device count in one day was 25K. So I had 25,000 users on V6 only network. And not so many bugs reported. 12 bugs in total, and we got 4 of them fixed. Mostly internal stuff, but we also reported a number of external applications. So remember those questions I wanted to get answered during the pilot? What percentage of users need before? As I said, we got about 5% explicitly falling back, and 10% were just staying on 2.4 and were not even affected by this project. As for Wi-Fi and for wired, as I say, 5 devices per site maximum, except special locations with treadmills. As a result, we saved a lot of address space. For Wi-Fi, our DHCP pool utilization dropped by 5 to 8 times, which actually matches 15% of users staying on dual stack. So we basically were able to downsize DHCP pools by 4, in some cases 8 times, which again was huge saving of address space. And for wires, we basically reclaimed hundreds of thousands of IPs. What did not work? Well, I think my current list is about 20 items. I have a special list of things which do not work. Top 5. Number 1 is definitely Gym Treadmills. Number 2, this one actually got a lot of complaints from users, and I need a community help here. Spotify application on laptop. It works perfectly fine on phones. It works in the browser mode, but if you're using a dedicated app on macOS and I think on Windows as well, it's very unhappy if there's no IPv4. So please If you ever use Spotify, click on this link and upload the feature request I opened with them to get that fixed. Well, the third thing is VPN. We knew it's gonna happen. There is no reason why VPN as a protocol would not work over IPv6 only, and it does work if VPN server is properly configured. Unfortunately, in many cases, server administrators do not enable IPv6 on their VPN system, and as a result, servers just do not want to establish a connection with a client which doesn't have IPv4 address. But again, it's not a protocol problem, it's just configuration issue on remote side. Well, yeah, some people complained about StarCraft not working. I am not sure it was business critical application, but people are unhappy. Also, I got reports about macOS recovery image not working over v6 only, but also what I've heard is that it's going away, so probably it's not such a big of an issue. One of the important questions for us was how we're going to provide fallback mechanism for users who need IPv4, because I never expected that we can migrate all users. I understand some of them would need IPv4. So one of our options were, okay, maybe we can use dedicated SSID, we can use dedicated network, but how are we going to do that? For wired network, what we're doing currently, user must open a ticket and tell us that they need IPv4, because we want to know who those users are and why they need IPv4. And we're only granting them that exception for 18 months, because we do not want users to relax and sit forever and do nothing about fixing their application. For Wi-Fi, we ended up doing dedicated SSID, but it's not the best strategy, and I'll explain a little bit later why. Any showstoppers? No, we actually did not discover anything to block the project, because we were providing a mechanism for users to get dual stack if they need it. Obviously, your experience may vary because it depends on the use cases and devices on the network. For example, my laptop has been sitting on v6 only network since the start of the pilot, so for at least 2.5 years, and I'm perfectly happy, but my use case is mostly SSH and browser. People with millions of applications on Windows laptops might have different experience. Support team impact, surprisingly, was very little, but we planned ahead. We notified the users about the change. Notification email contains the link to report the issue and the first step, how to recover, how to switch to dual stack. So as a result, most of the users actually didn't even need to talk to support team. But in case they do, support team were provided with a troubleshooting flowchart. They had a link to known issue page, so they could check if the issue has been reported already and how to troubleshoot it. Lessons learned. Well, the most important lesson I've learned, never allow your tech support to disable IPv6 on user devices. We found a number of cases when users just had IPv6 disabled on the laptops, so obviously nothing worked for them. Why? Because a while ago it was some issue, and tech support people decided as a workaround, advise users, oh, just disable IPv6. Once you do this, there is no way you can come back, find out how many people did that, do they still have v6 disabled or not, until you turn off IPv4 and that problem backfires. Also, until you turn off IPv4, you're not really getting operational experience with v6. What you get is happy eyeballs, and it's completely different story, right? We found a number of issues which were not visible to us at all, thanks to happy eyeballs, until we disable IPv4, right? First of all, we found a lot of vendor bugs. Very funny one. I can talk for hours, probably should be another presentation about what we found. Things like only UDP packets to particular source of destination ports are broken, and all that kind of funny things. We actually found an interesting problem with neighbor discovery design. Neighbor discovery state machine allows packets to be dropped all the time when a new device connecting to the network for the first few seconds. So there is an ITF draft which is going through working group last call currently to update the neighbor discovery state machine and to fix the issue. Also, there are a number of process issues we discovered. First of all, indeed, it's a mindset. People still think about IPv6 as a second-class citizen, so they never test P6 connectivity if before it's working and so on. We found a number of designs which claim to be IPv6 enabled, but they still had number of dependencies on IPv4. Like application might send IPv6 traffic, but it's never using IPv6 DNS, for example. So another lesson is that early adopters are crucial for the success. So we did this opt-in phase when we asked for volunteers, and it was a very good idea because we got people on board who are interested in V6, willing to try, willing to troubleshoot, and they're also capable of troubleshooting, so they can give you a report which are much more informative than just something doesn't work, right? They can help you, they can run TCP dump for you, and so on. As a result, when we switched majority of the users to V6 only, we already had some issues found and fixed, which allowed us to minimize the user impact and improve the user experience. Yeah, another thing is that it's a very good idea to start requesting IPv6 support from your vendors as early as possible, because obviously it takes years to get proper V6 support. But that request must be very explicit. I've seen RFPs say IPv6 must be supported. It basically means nothing. If your vendor tells you, my equipment supports IPv6, it most likely means you can configure an IPv6 address, right? It might not mean that that device can use IPv6 DNS. It doesn't necessarily mean device would receive DNS and router advertisement. It doesn't mean it could be managed over IPv6 and so on, right? So we have started making those requirements explicit and talking to all our vendors. So dedicated SSID, why it's not ideal? First of all, we actually spent a lot of time discussing what the name of that SSID should be. Our normal SSID is Google Guest. How should we name a fallback SSID? So the name is less attractive, so users still by default connect to Google Guest, but it's still attractive enough that if Google Guest does not work, users will try this one. Hard, right? Also, the problem is, in most of the cases, people do not know which SSID the device is connected to right now, because some devices have explicit preferences, some may make a decision based on the signal, and so on. So we actually found a number of cases when device which is supposed to be on V6 only SSID because it works very well, just decided to switch to dual stack, which basically increases IPv4 consumption and so on. So one of the options is actually do not broadcast the fallback SSID, so users need to explicitly configure it only if they need to. And also, once your device remembers the fallback SSID, there is always a chance it will be connected to it, even if V6 only is available and working. So it's hard. And for wired network, fallback is actually even harder, because for the guest network is just one segment for us. So we were able to create additional dual stack VLAN. But as I'm thinking about doing the same migration for internal network, when I have a lot of VLANs, it means that I would need to double number of VLANs in the network, which doesn't scale. So what we really need to make transition to IPv6 only smooth is ability for IPv6 only and IPv4 enabled hosts to coexist on the same network segment, on the same VLAN. And actually, there is a draft in DHC working group, which is currently with RFC editors and will be published soon, which describes how we can utilize DHCP-v4 mechanism to allow coexistence of IPv6 only and IPv4 enabled hosts together. So the current status of this is that we have completed the migration of our offices to IPv6 only network. So vast majority of them are now V6 only. So when all this COVID insanity is over and you decide to come and see us in one of our locations, your device will be connected to IPv6 only guest network. So that's all I have for today. So believe me or not, IPv6 only enterprise networks, or maybe let's call them IPv6 mostly enterprise networks, are actually possible. And I guess now we have time for questions.
Thank you very much, Jen. Somebody is asking if you enabled high availability on the NAT64 and DNS64 guest network, and if so, how?
So actually, for NAT64, we were using the same devices which we were using for normal NAT44. So we had the same level of high availability because we have a cluster of firewalls. So the same set of devices which were initially even for NAT44 mode in high availability mode. So we did not do anything special. We basically enabled additional form of NAT on the same set of devices. And for DNS64, well, I got lucky. I was using Google public DNS64. So it's because it's SWIP and the whole Google infrastructure is providing enough high availability for us.
Someone is asking if the recording or presentation will be made available. This, along with all of the other presentations, will be made available a few weeks after the conference closes. We don't have any other questions, but Jen, I was wondering if you had a favorite war story to share.
I actually have two, and I cannot make my mind which I like more. So one was quite funny. We noticed that when I connect to V6 only network, which we did not even make public at that state, my device has IPv6 connectivity for 5 seconds, and then it disappears until the next array came. Apparently what happened, we had a smart wireless device, which was trying to do kind of ND proxy, and it was trying to respond to neighbor solicitation from my laptop for default router address. But when responding, it was actually clearing up RBit in NA, which means it was telling my device I'm not a router anymore. So my device was losing default gateway, and as a result, the whole V6 connectivity after 5 seconds. And the second funny story was my colleague complained that DNS packets, some of them are disappearing on V6 only network. And what we discovered, the issue was affected UDP packets with some particular source port. And because different platforms using different set of source ports for DNS packets, it was only affecting some platforms. And we found that another type of equipment was actually trying to drop IPv6 MLD packets, and it was looking for ICMPv6 type in the packet without even checking that it's actually ICMPv6. And as a result, some source ports in UDP looked for that device as particular IPv6 MLD packets. So those packets were dropped. Yeah, so we spent some time here troubleshooting that kind of funny things.
What was the most unexpected yet positive feedback you've heard from the V6 switchover?
Unexpected. Actually, I was surprised that how many people actually responded to our announcement saying, oh, yeah, that's really cool. Thank you very much for doing this. Because we did have some requests from some developers asking, could you please give us V6 only networks? But I did not expect that so many engineers, at least, were actually really happy to see it happening, because it actually allowed them to do dog fooding and find out what kind of V6 problems their products have.
Well, thank you very much, Jen.